Hello, this video is for Module 3 Part 1 and includes a discussion of the elementary perceptual tasks, which are part of data visualization. Okay, let's go ahead and get started then. So Cleveland and McGill define an elementary perceptual task, or EPT for short, as a visual task used to extract a value that is represented in a graph. They present the following figure and they identify some of the common EPTs. In this module here, I'm going to discuss some of these, but not all. One of the most important EPTs, or most useful EPTs, is the idea of position. So let's just consider the following graph where we have the amount spent on healthcare as a percentage of GDP for Asian countries. And we can see quite easily that Japan is the highest on this graph at about 10%, a little over 10%. And Myanmar is the lowest here. Okay? So what other things can I learn from this graph? Well, I can learn that Singapore, Thailand, and the Philippines are about halfway, or about 5% it looks like, compared to Japan, which is at about 10%. Now my brain is using the notion of a position EPT to do this. Okay, so I can see the bar here is at about 10, and these bars here are at about 5. So at a very elementary level, my brain is using the notion of position to determine the values on this graph. So we can do this pretty efficiently. So we can determine position on a scale pretty easily. Our brains can do that pretty well. So here I've just made a very simple schematic where this here represents 2, okay? Just pause for a moment and give me a guess for what this value represents. So if this is at position 2 here vertically, what is this positioned at? Okay, if you said 4, okay, that's what it actually is 4 here. Okay? Now we're able to do that because, again, we're pretty good with determining position along an aligned scale. So what we mean by aligned here is they start at the same position on the bottom, which is the case on this graph here. These are all aligned with 0 along the bottom there. If I add a guide, which here I am adding a guide of grid lines, I can make it even easier for you to understand or try to estimate that value. So if I know that 2 here goes up 2 grid lines, if this position is up at 4 grid lines, then I know that it's just double the value of 2 here. So sometimes we use grid lines to assist us in understanding or estimating values here. Another EPT is length. So let's consider the following graph again on the percent of GDP spent on healthcare versus social care for a few countries here around the world. So what do we learn from this graph? Well, we have the US here in the middle, and we can see that they have the smallest amount spent on social care. Now our minds can do that even though these darker blue boxes are not all aligned with one another. So the height or the length of that box there is smallest relative to all the others on the list here. So we can say that the United States spends the least on social care compared to these other countries. Now it turns out in this particular graphic that the healthcare boxes, okay, are aligned because those are all on the bottom here, but the social care boxes are not aligned. But once again, our minds are pretty good at estimating values for lengths. So if this here represents 10, that length represents 10, Just pause and take a guess at what you think this value represents over here. So this value here is actually 30. If you take 3 of these lengths, you'll get up to the total length of this line on the right there. Once again, our ability to use grid lines is going to make that even easier. Angle is another EPT that is used from time to time, and our minds are not as good at estimating a value based on an angle when compared to the notion of length or position. Angle is sometimes used in situations that I have presented here where I have something happening, it looks like before surgery and then after surgery, or during follow-up here. And what we're doing is representing how much change there was from before surgery to the follow-up setting or before discharge. Now they have presented 4 different graphs here, which we'll talk more about that in the next module. We actually call that faceting when they present similar information across 4 different graphs. When you're doing faceting, you want to make sure that the scales are the same here. They go from 0 to 100, 0 to 100, 0 to 100, and then this one actually goes from 0 to 80. So that's not a best practice there. We'd like all of those scales to be the same. But what do I learn from this graph? Well, I can see that the amount of change seems to be the most here for C in this graph. And this is for the percent of moderate to severe RAVVR, whatever that is. And then they're doing that on a 1-match repair. I think this is something about heart surgeries, if I'm not mistaken. But we can see that the change is the most here in C. We can also see things quite easily with angle on this graph. I can see that I have one patient that actually increased there. Okay, so if this is a surgery to try to improve things, that didn't work for that particular patient. But that's really easy to see because that angle is flipped up where all the others are flipped down here. Here's another one in this group. You can see that one also increasing where all the others are going down. So there's certain aspects of angle that are easy to pick out, just like direction here, if it's increasing or decreasing. But if I do something like the following, it's a little bit more difficult. So here I have just weight loss from last year to this year for person A and person B. Person B here has lost 5 pounds. So how much weight do you think person A has lost? Okay, this is a little bit harder because angle, again, is not a very efficient EPT for our minds to use. It looks like it's more than 10. Okay, the steepness here looks like it's more than double that. But I don't know if it's 12 or 15 or 18 or, I don't know, might even be 20 pounds. I'm not sure. It's hard for me to tell what that drop is relative to that drop. Again, that's hard because angle is being used, and that's not a very efficient EPT for our mind. If I just redraw this graph or provide an alternative representation of this information, so here I have person B on the right and person A on the left. The amount of weight loss here is 5 pounds. How much is the weight loss here for person B? Again, this is the same information that's represented in this graph, but it's just represented in a different way. And here what I'm doing is using position to try to estimate this value. And it looks more clearly that it's going to be about 15 pounds. This here is about 3 times larger than that drop here. Again, my brain can do that more easily because position is an easier EPT to use than angle is. So if given the choice between these two, you might want to use something like this graph because it's easier for us to understand what those values are and to make comparisons across those values. Now, if we go back to this chart, this here might have this does have lots of information presented, and it might not be the best to present that with side-by-side bar graphs like this. I would have to do that for lots of different people. I would have to do that for different situations, and I might just have too many bars to compare. So that might be why the authors decided to use this representation of their data, just because they had so much information that they wanted to share. So it's not that angle is a bad thing to use, okay? It's just if you want them to be able to estimate specific values, that's going to be hard to do. Okay, how about the last one that I'm going to be talking about, area. So this here is called a tree map. Okay, I have information about healthcare spending in California. This first bluish set of boxes is for private or other government payers. This orange color here is for Medicare, and then the green on the right is for Medicaid. So the blue boxes kind of go together. We call that a similarity principle. The orange boxes kind of go together and the green boxes go together. That's called a Gestalt, or that is part of the Gestalt principles, which we'll be talking about in our next module. But here, what I need to do is use the EPT of area to try to figure out what's going on with these values. So I can see that physician and clinical care seems to be the biggest box of all the other blue boxes here. So they're spending the most on that particular item inside of private and other government payers. Hospital care isn't as big as, at least it doesn't appear to be as big as physical and clinical care. It is a little bit taller, it seems, but it's not as wide. So I think the area of this box here is bigger than the area of this box. It's a little easier to see that over here in the Medicare. For the Medicare, we can see that the healthcare box here is somewhat bigger than the physician and clinical care box. How much bigger? Again, that gets to be hard. Is this 30% bigger than that box? Is this 50% bigger than that box? Again, that's hard for my mind to figure out. Also in Medicare, I can see that the hospital care tends to be the biggest box as well. So certainly broad comparisons of area can be done, okay, but not smaller comparisons. So are these two boxes really different sizes here? Other professional and other medical products? I can't really tell because area is not a very good way to compare values. Here's another one that has been just another example, I guess. Here's Group A, Group B, and Group C. And I just want you to take a moment and try to guess or estimate the value of the question mark there. So if this represents 25% in Group A, if this represents 10% in Group B, what percent is represented here in Group C? You might be surprised that that value is actually 40%. Again, this here, the dark gray, is 40% of that box in Group C. Even though 40%, that box isn't nearly as tall as the 25%, but again, we're basing that on the area. Here's another area graph, but it only has two groups. Okay, and these are sometimes used in what's called 100% stacked column graphs, or some statisticians would call this a Mosaic plot. When I have only two groups and I'm able to align them with one another, I can estimate this value much easier than I can up here in this situation. This value right here looks like, well, if this represents 20% and the axes are aligned, then this looks like it represents about 40%, or maybe 45%. Again, because the axes are aligned, I can more easily estimate what that value is. So this is a simplified example of an area chart. We're not really actually using area here because I'm just trying to estimate the change here, or position, from the box on the right to the box on the left. So it's not really, my mind's not actually using area to make this comparison, it's using position. Whereas up here, I'm forced to use area because my axes are not aligned here. And this representation here is exactly what we have in this tree map. So if it's important to be able to distinguish between certain groups here, we shouldn't be using a tree map for that comparison. And for that matter, we shouldn't be using angle for a comparison of that nature. We should be using the notion of position or length if it's important to estimate those values carefully. Okay, the task then for this module is to actually just participate in an activity that I put together for EPTs. So if we click on that activity, what that's going to do, the first page is just some directions. If you proceed to the slides, you can do this activity. And I just want you to estimate these values here. So some of these slides are what I covered in the notes here. So some of these will be easier than others, but I have included some variations to what we've talked about in the notes. Once you get done with that activity, there's actually, I think, 12 slides to go through. I want you to take a look at the outcomes. So here are some outcomes where this column right here of the average is the average value for anybody that has completed this activity. Okay, so I had 5 people complete this activity for us ahead of time. These will just increase as more and more students complete this activity. The value here, okay, the real value is what that value should be. So it looks like we're doing really good on this first one, which is just the position aligned scale. That's the easy one there. I'll ask you to talk about the bias, and what the bias is just how far off we are of target. So down here you can see that if I take 4, which is the real value, okay, and also our average value from everybody that did this activity, that's 4 as well. So we're right on the mark here. Our bias is 0 for that situation. However, if I look at this one here where I have some distractions in place, it's harder to determine that value. It's not as easy. So there's more bias there. We are off the mark here. The real value was actually 1.33, but these people, these 5 people, their average value says that it was 1.8. So that's off the mark there. They have more bias. So I want you to just talk about the amount of bias and which EPTs tend to have the least. Bias near 0 will be the least. Some of the slides have distractions in place, so just take a look at, generally speaking, what happens to the bias when I have those distractions in place. And then finally, question number 3 here is just to try to interpret this pie chart and talk about what EPTs, okay, are being used when I try to understand what's going on with this pie chart. So just answer those 3 questions and make sure and submit those, because you'll get credit for submitting those. And that's all for this video on EPTs. Thank you. Have a good evening.